Welcome to this session on the Azure Data Platform. In any information technology system, data is at the very heart of everything. Without data, applications and services simply have no purpose. They store nothing, process nothing, and deliver nothing of value. So when we move to the cloud, one of the most critical decisions we make is how we handle our databases. In this session, we will explore the database options that Microsoft Azure provides. We will look at two fundamentally different approaches: running SQL Server on a virtual machine, which is the infrastructure as a service model, and using Azure's managed database service, which is the platform as a service model, also called database as a service. By the end of this chapter, you will understand how to choose between these two approaches, how to set them up, how to manage them, and how to make the most of the broader Azure data and analytics ecosystem. Let's begin. Before we dive in, let us take a quick look at what we will be covering in this chapter. We have 5 main topics. First, we will look at Azure database options overall, understanding the choice between infrastructure as a service and platform as a service for SQL Server. Second, we will go deep into SQL Server as infrastructure as a service, what it means to run SQL Server on an Azure virtual machine, how to create and configure it, and how to manage it day to day. Third, we will cover high availability for SQL Server in Azure virtual machines, looking at options like always-on failover cluster instances, availability groups, database mirroring, and log shipping. Fourth, we move to the platform as a service world with Azure SQL Database, how to create it, understand its pricing models, and manage it through the Azure portal. And fifth, we will close with a look at the broader Azure Data and Analytics platform, the wider ecosystem of data services Microsoft provides in Azure. Let us start with the first topic. When it comes to running SQL Server in Azure, you have 2 main paths to choose from, and it is important to understand what each one means before you commit to a direction. The first option is Infrastructure as a Service, or IaaS. In this model, you are essentially renting a virtual machine from Microsoft, and then you install and manage SQL Server yourself, just as you would on a physical server in your own data center. You get full control over the operating system, the SQL Server version, every configuration setting, and every feature. If you need something specific that only the full version of SQL Server offers, this is your path. The trade-off is that you are responsible for everything: patching, backups, performance tuning, and keeping the server running. The second option is Platform as a Service, sometimes called Database as a Service or DaaS. This is where Microsoft manages the infrastructure, the operating system, patching, and most of the maintenance for you. You simply provision a database, connect to it, and start working. You have fewer configuration options, but far less operational overhead. So when should you choose each one? Choose IaaS when you're migrating an existing on-premises workload and need full SQL Server features, or when you have a complex configuration that requires direct access to the server. Choose PaaS when you're building cloud-native applications, when you want Azure to handle the heavy lifting of maintenance and availability, or when you need elastic scaling without managing infrastructure. Both models support Microsoft SQL Server, but they serve different needs. Understanding this distinction is the foundation of everything else in this chapter. Now let us look at how to actually set up SQL Server on an Azure virtual machine. You have 2 approaches. The first is to create a clean virtual machine with a standard Windows Server image and then install SQL Server yourself afterward, exactly as you would on a physical machine. This gives you full control over which version and edition of SQL Server you install. The second approach, and the one we will focus on here, is to choose a virtual machine image from the Azure Marketplace that already has SQL Server bundled in. For example, you can select an image like SQL Server 2016 Service Pack 1 Enterprise Edition on Windows Server 2016. Azure will provision the virtual machine and configure the SQL Server instance for you during deployment, saving you time. When creating the virtual machine, you'll need to fill in a set of basic configuration values: the machine name, your preferred disk type, an administrator username and password, your Azure subscription, a resource group, and the deployment region. Now here is an important recommendation. Always choose SSD as your disk type when running SQL Server. Disk input-output speed has a massive impact on SQL Server performance, and SSD disks dramatically outperform standard hard disk drives for database workloads. Similarly, when selecting the virtual machine size, choose a size with more CPU cores and more memory than you might think you need. SQL Server is a resource-hungry application, and giving it adequate computing power pays dividends in performance. The good news is that if you choose the wrong size initially, you can always change it later. This is one of the great benefits of cloud computing. You're never permanently locked into a particular machine size. When you create a virtual machine from a SQL Server image, you get an additional set of configuration options that are specific to SQL Server. Let us go through each of these in detail. The first is SQL connectivity. This controls who can connect to your SQL Server instance and from where. You have three options: VM only, which restricts access to applications running on the same machine. This is the most restrictive and least common in practice. Private, which allows connections from other virtual machines within the same virtual network. This is the recommended option in most scenarios. And public, which exposes SQL Server over the internet. You should avoid the public option unless you have an extremely strong reason, as it opens your databases to brute force attacks from anyone on the internet. The default port is 1433, but can be changed if needed. The second setting is SQL authentication. By default, SQL Server uses Windows authentication. However, if your application requires SQL login credentials with a username and password, you can enable SQL authentication here. When enabled, the virtual machine administrator credentials are automatically added as a SQL login. Third is automated patching. By default, this is configured to apply updates every Sunday at 2 in the morning. It is strongly recommended to leave this enabled so your SQL Server stays up to date with security patches. If you need to test updates before applying them in production, you can disable it, but then you take on the responsibility of keeping the server patched manually. Fourth is automated backup. This is disabled by default. When enabled, you can configure a storage account to receive the backups. Set a retention period between 1 and 30 days, optionally enable backup encryption, include system databases, and configure a detailed schedule ranging from every 5 minutes up to once per day. Finally, Azure Key Vault integration allows you to encrypt SQL Server keys and certificates using Azure's managed key storage service. And our services enables advanced in-database analytics using your programming language directly within SQL Server. Once your SQL Server virtual machine is deployed, how do you manage it? In the Azure portal, you'll find a special section called SQL Server Configuration, which is only available for virtual machines that were deployed from a SQL Server image. This blade gives you access to all the settings we just discussed: storage, connectivity, patching, backup, Key Vault, and our services, and you can adjust all of them at any point after deployment. Under Storage, you can view current storage usage and performance metrics. Under SQL Connectivity, you can change the access level, update the port number, and toggle SQL authentication on or off. To actually interact with your databases, you can use SQL Server Management Studio, often called SSMS, which you connect to from within the virtual machine itself or remotely from your laptop if you have enabled public or network access. Here is the really important point. Once you are connected to SQL Server on an Azure virtual machine, the experience is essentially identical to working with SQL Server on a physical server in your own office. You have access to every single feature: databases, tables, stored procedures, security, jobs, replication, everything. You can create databases, manage users, write queries, configure backups, monitor performance, all of it. There is no feature limitation because you're running the full version of SQL Server. This is what makes the IaaS model appealing to teams migrating from on-premises. The learning curve is minimal because the management experience is unchanged. Running SQL Server on a single virtual machine is fine for development and testing, but production workloads require high availability. If that one virtual machine goes down, everything goes with it. Azure supports the same high availability architectures for SQL Server on virtual machines as you would find in a traditional on-premises environment. There are 4 main options. The first is always on failover cluster instances. This is an instance-level high availability solution where SQL Server runs as a clustered service across 2 or more nodes with shared storage. If one node fails, SQL Server automatically fails over to another node. This provides a recovery point objective of essentially 0 for most failure scenarios, because the database files are shared. The second is always on availability groups. This is a database-level solution where one or more databases are synchronized across multiple replicas. You can have automatic failover between replicas, and secondary replicas can also serve as read-only endpoints to offload reporting queries. This is the most modern and flexible high-availability option. The third option is database mirroring. This is an older technology that creates a synchronized copy of a database on a standby server. While it still works, Microsoft has deprecated it in newer versions of SQL Server in favor of availability groups. The fourth option is log shipping. This involves automatically backing up the transaction log on the primary server, copying it to a standby server, and restoring it there on a schedule. It is the simplest of the 4 options to set up, but it has a higher recovery point objective because there is always a delay between when transactions are committed on the primary and when they are available on the standby. One critical note before we move on: if you plan to use any of these high availability options, you must configure the availability zone or availability set for your virtual machine at creation time. This cannot be done after the virtual machine has been deployed. Plan ahead. Now we move to the second major approach: running SQL Server as a platform as a service, more specifically as database as a service. This is a fundamentally different operational model. You're no longer dealing with virtual machines, operating systems, SQL Server installations, or infrastructure management. Instead, Microsoft handles all of that behind the scenes. You provision a database, connect to it, and use it. What does this mean in practice? It means you do not have direct access to the underlying SQL Server engine in the same way you do with a virtual machine. You cannot log into the server, restart services, or modify system configurations. Some advanced SQL Server features that require OS-level access are not available. But here's what you gain. Microsoft automatically handles all patching and updates. Backups are built in. High availability is enabled by default with geo-redundant storage. Scaling can be done with a few clicks or automatically. And billing is precise. You pay per second only for what you use. For cloud-native applications and modern development teams, this is often the ideal choice. The team focuses entirely on the application and the data, while Azure manages the infrastructure. Less to maintain means fewer things that can go wrong. Let us look at how to create an Azure SQL database. Creating an Azure SQL database involves 5 main steps, and the process is straightforward from the Azure portal. Step 1 is the basic configuration. You provide a database name, select your Azure subscription, and choose or create a resource group. These are the standard building blocks you use for all Azure resources. Step 2 is choosing the database source. You have 3 options. Blank creates an empty database ready for your schema and data. Sample provisions the database with Microsoft's AdventureWorks LT sample dataset, which is great for learning and testing. And from backup lets you restore a previously exported database backup, useful for migrations from other environments. Step 3 is providing a server. Every Azure SQL database must belong to a logical server. If you already have one, you can select it. If not, you create a new one by providing a unique server name. This becomes part of the public endpoint URL, for example, your server name.database.windows.net, along with an administrator username, password, and the Azure region where the server will be hosted. Step 4 is selecting the pricing tier, which we will cover in detail in the next slide. This determines how much compute and storage capacity your database has. And step 5 is deciding whether to use an elastic pool, which is a resource sharing model we will also explain shortly. One thing worth noting is that the default database collation is SQL_Latin 1_general_CI_AS, and this cannot be changed at creation time. Make sure this works for your application's language and sorting requirements before you proceed. Deployment time varies depending on whether you're creating a blank database or restoring from a backup. Larger backups naturally take longer to provision. Pricing for Azure SQL Database can feel confusing at first. So let us break it down clearly. There are two pricing models. The first model is the DTU-based model, where DTU stands for Database Transaction Unit. A DTU is a blended measurement that combines CPU, memory, data input-output, and transaction log input-output into a single number. The idea was to simplify resource selection, but in practice, many people find it difficult to translate their on-premises workload characteristics into DTU values. The DTU model has 3 service tiers. Basic gives you 5 DTUs and up to 2 GB of storage, suitable for very light workloads or development. Standard gives you up to 3,000 DTUs and up to 1 TB of storage, covering most typical business workloads. Premium goes up to 4,000 DTUs and up to 4 TB of storage, designed for mission-critical, high-throughput applications. The second model is the vCore-based model, which Microsoft introduced more recently to address the complexity of the DTU model. In this model, you simply choose how many virtual CPU cores you need, anywhere from 2 to 80, and the memory scales proportionally from 5.5 GB up to 408 GB. This feels much more familiar to anyone who has sized a server before. The vCore model also has an important advantage. It supports the Azure Hybrid benefit, which allows you to use your existing on-premises SQL Server licenses to reduce costs when running in Azure. The key thing to remember about pricing for both models is that Azure SQL Database is priced per database. The server is free, so whether you have 10 databases spread across 10 different servers, or all 10 on a single server, you pay the same, based on the number and tier of databases, not the number of servers. And if you pick the wrong tier, no problem. You can change the tier at any time, and the transition happens with minimal downtime. Now let us talk about elastic pools, a pricing and resource model that is particularly well-suited to multi-tenant applications and global services. Instead of allocating dedicated resources to each individual database, an elastic pool creates a shared pool of resources, either in DTUs or vCores, that multiple databases can draw from dynamically. You pay for the pool, not for each individual database separately. Here is why this is powerful. Most databases do not have a constant, steady workload. They have peaks and valleys throughout the day. In a single database model, you have to provision enough resources for each database's peak, which means you are paying for capacity that sits idle most of the time. With an elastic pool, databases share resources intelligently. When one database is busy, it can temporarily consume more of the pool's capacity. When it is quiet, another database can use those resources instead. Consider this real-world example. Imagine you are hosting applications for clients around the world. A client based in Europe will have peak database activity during European business hours, and their database will be relatively quiet during business hours in the United States. Meanwhile, your American client's database peaks during American business hours. By placing both databases in an elastic pool, the pool's resources are efficiently shared between them across different time zones. However, elastic pools are not always the right choice. If all your databases peak at the same time, for example, because they all serve the same geographic region and have the same working hours, then an elastic pool does not help. Each database will try to consume peak resources simultaneously, and they will compete with each other. In that scenario, dedicated per database pricing is the better approach. Both the DTU and vCore pricing models are available for elastic pools, so you have the same flexibility regardless of which resource model you prefer. Once your Azure SQL database is deployed, managing it looks quite different from managing SQL Server on a virtual machine, but in many ways it is actually simpler and more powerful. Let us walk through the key management features available in the Azure portal. The first thing you need to configure is the firewall settings. By default, only other Azure services can connect to your Azure SQL database. If you want to connect from your laptop, your office, or any external system, you need to add firewall rules allowing those IP addresses. The Azure portal can automatically detect your current IP address and add it for you. One important note: after adding or changing firewall rules, you must click the Save button. It is easy to forget this, and if you do, the rules simply do not apply. This has caught many developers off guard. Once your firewall is set up, You can connect using SQL Server Management Studio from your computer. However, there is a much more convenient option built directly into the Azure portal, the Web Query Editor. This allows you to write and execute SQL queries directly from your browser. No additional tools required. For many day-to-day tasks, this is entirely sufficient. Under Settings, you will find several features unique to Azure SQL that have no equivalent in traditional on-premises SQL Server. Geo-replication allows you to create readable secondary copies of your database in one or more Azure regions around the world. This supports both disaster recovery and read-scale scenarios. Connection Strings provides ready-made connection strings for all major programming languages and frameworks, ASP.NET, JDBC, ODBC, PHP, and others, so you can quickly integrate your application. Sync to other databases lets you create synchronization groups so that data in your Azure SQL database is automatically kept in sync with other databases without any custom development. And Azure Search Integration allows you to connect your database to Azure Cognitive Search, enabling full-text search capabilities across your data with no additional coding required. The Configure option under Settings lets you change the pricing tier of your database at any time, scaling up for more performance or scaling down to save costs. Let us now compare Azure SQL Database with traditional on-premises SQL Server side by side, so you have a clear picture of what you gain and what you give up when you move to the platform as a service model. Starting with operating system access. On-premises SQL Server gives you full access to the underlying operating system. With Azure SQL Database, you have no OS access at all. Microsoft manages the OS layer completely. SQL Server configuration. On premises, you have full control over every SQL Server setting. With Azure SQL, configuration options are limited to what Microsoft exposes through the portal and APIs. Backup management. On premises, you are responsible for configuring and running backups. With Azure SQL, backups are fully automated by Microsoft. You do not need to think about them. Patching. On premises, you control when and how patches are applied. With Azure SQL, Microsoft handles all patching automatically. High availability. On premises, you must design and implement your own high availability solution, which requires additional servers, configuration, and ongoing management. Azure SQL has built-in geo-redundant high availability by default. Scaling. On premises, adding capacity means procuring new hardware, which takes time and money. With Azure SQL, you click a button and the database scales within minutes. Query editing. On premises, you install SQL Server Management Studio on your laptop. With Azure SQL, there's a built-in web query editor right in the browser. Geo-replication. On premises, setting up cross-region replication is complex and expensive. Azure SQL makes it a few clicks. And finally, cost model. On-premises use is capital expenditure. You buy hardware. Azure SQL use is operational expenditure. You pay by the second for what you use. The summary is this. Azure SQL Database trades some administrative flexibility for dramatically reduced operational complexity. For most modern applications, this is a very worthwhile trade. Before we close, let us cover connection strings and consolidate the most important best practices from this chapter. A connection string is what your application uses to connect to the database. The Azure portal provides ready-made connection strings for every major programming language. For ASP.NET, the string includes the server address, which is your server name followed by .database.windows.net on port 1433, the database name, the username and password, and connection security settings. You simply copy this string, substitute your credentials, and paste it into your application configuration. Now, for the best practices. First, and most importantly, never expose SQL Server to the public internet when running on a virtual machine. Always use private connectivity within the virtual network. Exposing port 1433 publicly makes your database a target for brute force attacks from anywhere in the world. Use a VPN, private endpoint, or application gateway to secure remote access instead. Second, in Azure SQL Database, always click Save after modifying firewall rules. This is a very common mistake. You could spend a long time troubleshooting a connectivity issue only to realize the new firewall rule was never saved. Third, both the DDU and vCore pricing tiers are completely flexible. You can change them at any time. Do not over-optimize early. Start with a reasonable size, monitor your workload, and adjust as you learn how the database behaves in production. Fourth, if you're building a multi-tenant application serving users in multiple time zones or regions, seriously consider elastic pools. The cost savings can be significant when your databases have naturally staggered usage patterns. These principles will save you considerable time, money, and frustration as you work with Azure databases in real-world projects. Let us close with the 6 key takeaways from this chapter. Number 1. IaaS SQL Server gives you full control. If you need every SQL Server feature, require OS-level access, or are lifting and shifting an existing workload from on-premises, IaaS is the right model. You manage more, but nothing is hidden from you. Number 2. Azure SQL Database as Platform as a Service dramatically reduces management overhead. Microsoft handles patching, backups, and high availability by default. Your team can focus on data and application logic rather than infrastructure. Number 3. The DTU pricing model is simple but opaque. It bundles multiple resource dimensions into a single number that can be difficult to map from your on-premises experience. The vCore model is more transparent because it directly maps to familiar concepts of CPU cores and gigabytes of memory. Number 4. Elastic pools offer significant cost savings for multi-tenant applications where different databases have different peak usage times. The resource sharing model means you pay for capacity once and distribute it dynamically across all databases in the pool. Number 5. If you're planning to set up high availability for SQL Server on an Azure virtual machine, configure the availability zone and availability set at the time you create the virtual machine. This is a hard requirement. It cannot be added or changed after deployment. And number 6. Azure SQL Database is not just a hosted version of SQL Server. It comes with cloud-native capabilities built in, geo-replication with a few clicks, full-text search integration, cross-database synchronization, and a browser-based query editor. These features remove complexity that would otherwise require significant engineering effort on-premises. That concludes our chapter on the Azure Data Platform. In the next chapter, we will explore more of the broader Azure Data and Analytics services, including Azure Cosmos DB, Azure Data Factory, Azure Synapse Analytics, and more. Thank you for watching.